Good evening, my 11th standard warriors. Welcome to the next session of work and kinetic energy theorem. This is session number 2. Last lecture we had spoken about work, how to calculate work by constant force and how to calculate work done by a force which is varying via integration and area under the curve. Also seen the different sign conventions, and today's session number 2 we are going to see the work kinetic energy theorem. We are also going to see what's kinetic energy and what is conservative and non-conservative forces. So this is Shreyas here, and I am the physics master teacher. Hello Saja, hello Harita, hello Aniket, Priya, hello Roshni, hello Neeraj, hello Ishpreet. Welcome Ankit, hello everyone. कैसे हो आप लोग? Anu is very excited. Nice to see that. Priya is also excited. Looks like the first lecture was very interesting. And yes guys, why not? Ishpreet, I'm very good bacha log. Suchi, I'm very good. Hello EGL, Sriram. Hello Lakshmi, Narsimhan. Welcome aboard. Hello Pradeep. Hello Saja. Okay Saja, I'll do check it out definitely. Hello Yunesh. So guys, agar aap, if you want to interact with me and you want to check out my profile, just go to Instagram and just check it out. So this is a schedule for the week in case you have missed the first class of what is work. It was conducted on Tuesday, so please check it out. And if you are a 12th standard student, check out the ones in the white color. So the ones in the white are for the 12th standard students. Also remember, the PDF of the session will be uploaded in the Telegram link which is there in the description box below. Now what and all is there in the Telegram group? You will get updates, important information, PDFs, solution of the homework problem, all of that. I had given a homework problem just in a previous class. So in case you have solved it, probably it should be there in the comment section. So we can just go, and there we go. There is work, power and energy. And let's go a little bit below and see who and all have done the homework. Some people have really lit the chat box with fire. And thank you Ishpreet, thank you Vikram. Well, Harita has also solved the second question. First question probably she was not able to do it, but no problem, good. Well, thank you Rokshna. Hello, well, Saja has enjoyed it, Kalyani has enjoyed it, Jaya also has enjoyed, Rokshna, Neeraj, okay, Kritugga, very good, Jitesh solved the homework, Paulami, and hit movies. Yes, it is enough for NEET. Yes, it is. Yeah, it is me, says mast hai lecture. Bahut hi badhiya. Very good, thank you. Okay, so let's get going. Oh, somebody forgot to post it. No problem. Maybe you can post it for today's homework, and definitely I'll read out your names in the next class. So let's talk about what is a conservative force. Okay, so what's a conservative force? Now, like the name suggests, it is conserving something. Let us see what it is. Remember, there are certain things, like for example, gravity. If you take an object and you move it anywhere and bring it back to the same point, then the total work done by such forces is zero. Many students have this confusion in their head. Sir, work is force into displacement, so if displacement is zero, is work zero? Well, the answer is not always. If displacement is zero, I mean, see, displacement can be zero by two ways. For example, if I say displacement is zero, then it is possible that it did not move only, it is at rest. In that case, obviously work is zero. Obviously, if it did not move at all. But there is one more possibility when displacement is zero. How? It went like this and came back to the same point. This is called as a closed path. What is it called? It is called as a closed path. There were intermediate displacements, but the total displacement is zero. That's what it is. So displacement is zero. That means initial and final position are zero. So there are two possibilities. One is the object didn't move at all. The second possibility is it moved, but it came back to the same point. So initial position is equal to the final position. There were intermediate displacements. Displacement. The total displacement is zero. I hope this makes sense. Okay. Now the thing is, in the first case the work is zero. Why work is zero? Because displacement didn't happen only. It was at rest. But in the second case, the work in this closed path may or may not be 0. There are two possibilities. You'll be like, sir, what the hell? Is it possible? Really? Well, I'll tell you one example. Look at this. Imagine I have some mass. Okay? This mass is M. I take this up. Okay, I take this up. I take this like this. Then I bring it down like this and I bring it back over here. In these 4 individual displacements, gravity is acting and is doing probably work. How? In this case, remember, mg is always downwards. Gravitational force is always downwards. From here to here, the work done is negative because displacement is up, force is down, so it is minus mg. Let's say I call it h. This is also h. This is l. This is l. L, L, h, h. Okay. So this is minus mgl. Minus mgh. Sorry. Minus mgh. Everybody agrees with this? From here to here. From here to here, the force is perpendicular to the displacement. So the work done will be 0 because it is perpendicular. Remember, fs cos theta. Gone. 0. Similarly, from here to here, force is down, displacement is down. So what will be the work? mg plus h. So mgh. From here to here, force is perpendicular to the displacement. Work done is 0. So what is the total work done? What is the total work done? Minus mgh plus 0 plus mgh plus 0, minus plus cancels, so answer is 0. So the total work done in a closed path may be 0. You can see that, yes, definitely it is 0. Everybody seeing that? Total work done is 0. Now, this is not just true for this particular path. Even if somebody had chosen some weird path like this, and like this, or like this, every time the work will come out to be 0. I've just taken a special example, but every time you can break it down into height, length. Whatever work it does while going up, same work it does while coming down. Lateral displacement, this kind of horizontal displacement does not matter. The work is done only while going up or coming down, and effectively the total work will be 0. Yes. So what is that symbol before work? That is called as summation. This is sum, adding all the works. Now, so what we got is for gravity, for forces like gravity, so maybe 0. So that is like gravity, it came out to be 0. Let's take another example for say like this. Okay, this is a block, okay, and it is kept on a surface over here. I hope you can visualize it. This is a horizontal table which is very, very rough, let's say. Okay, and what I do is I move this box. Okay, I move this box once here, then once like this, then once like this, and then once like this. Okay, let's say this is L, this is B, this is L, this is B. So what will happen when I move it like this, I'm making sure it is coming back to the same point. There will be friction acting because it is rough. How will friction act? When it is going from here to here, friction will act this way. Look at that, friction will act like this, right? Because normal will be like that, mg will be like that, friction will be backwards. From here to here, friction will act like this. From here to here, friction will oppose the motion, and from here to here, friction will act like this. Are you able to understand this, guys? This is how friction will act in every situation. Yep, everybody clear? Now, so in closed path is triangle means what is the displacement? Unish, it will still be 0. Any shape does not matter, be it circle, triangle. As long as initial and final positions are same, displacement is 0. Okay. Now, if I ask you what is the total work done, it will be negative because force is always opposite to the displacement. So minus FL, look at that, friction into length with negative sign, minus FB, minus FL, minus FB. All the work have been added up individually. Each work is negative. So this will become minus 2FL minus 2FB, which is obviously not going to be 0. Obviously, this is going to be a negative number no matter what you do. So that means it may not be 0 like in the case of friction. So what did you learn from all these examples? There are some forces like gravity. When you bring it back to the same point, the work done by that kind of force like gravity is zero. But there are some other kind of forces like friction. When you bring it back to the same point, the total work is not zero. So even when the total displacement is zero, the total work may be zero or may not be zero. Did you see that? Did you see that? Yes. Look at this. Lakshan, I'll be teaching transformers next week in Pathfinder, don't worry. So what has just happened is every time displacement, force opposite, displacement, force opposite, displacement, force was opposite. So in this case, it so happened if you just added individual works, you got the total work to be a non-zero number. In this case, it came out to be negative. Yuvnesh, can you just replay this part again? You can just take the slider a little bit behind and you can start it from beginning, right from the beginning, because then you will miss out something then. So the idea is there are two kinds of forces. So there are two kinds of forces. So the forces in which, you start from a point and come back to the same point. Remember, displacement is zero. That is, initial position is equal to final position. And you find that the total work is zero. When the total work is zero, then the type of force is called as a conservative force. What is it called? It is called as a conservative force. Keep this in mind. Next thing, if suppose the work done is not zero, example, in that case, like friction, then it is obviously going to be called as non-conservative force. That's it. As simple as that. Now, what kind of forces are conservative? What kind of forces are non-conservative? You can take examples just like I did. You can start from a point, you can go here, go down, go up like this and see if the total work is zero. And if it always comes out to be zero, no matter how you take the path, then it has to be conservative. But if there is even one path, I will repeat this statement, even if there is one path where you find that when you bring it back to the same point, the total work is not zero, then it must be non-conservative in nature. Even if you see that there are other paths where the work done may be zero. Even if there is one path where you get non-zero work, that has to be non-conservative in nature. Now, if you remember from your 9th and 10th grade, gravitational force is like G m1 m2 divided by r square. You will see in 12th standard, electric force is K q1 q2 by r square. Instead of mass, you have charges. Instead of gravitational constant, you have Coulomb's constant. So the nature of gravity and electrostatic must be similar in nature. So if gravitational force is conservative, shouldn't electrostatic force be conservative? Think about it and let me know. Think about it and let me know. Is mechanical energy conservative? No, Mohit Raj, it's an invalid statement. Mechanical energy is conservative is a wrong statement because it's not a force. Forces are conservative or non-conservative. Energy is conservative or non-conservative, that's a completely different story altogether. So that's the idea. Now what kind of forces will be non-conservative? All evil forces like friction, viscous drag or air resistance, they are non-conservative forces, including tension and normal. I will repeat, tension and normal will also be non-conservative, just like friction and viscosity, or you will learn about viscous forces and air resistance in a separate chapter. But remember, viscous force or drag force or air resistance forces are forces which liquids or air exerts on other bodies which are moving in it. Like when you are traveling on a scooter, you feel that wind and you feel that resistive force. That's air resistance or viscous force of the wind on you. Okay, normal and tension are also non-conservative. Example, imagine you have a dog. Okay, you have a dog. So this is our dog. Yeah, beautiful dog. Okay, beautiful tail. And you have tied it. Okay, and you pull it. So this is this Pandu who is taking this dog out like this. Okay, and what this Pandu does, he pulls the dog, he applies some tension, the dog is not willing to move, and you take the dog around like this and come back to the same point. You take the dog around like this, so this is the path, and you bring it to the same point. Every time the tension is parallel to the path, tension and displacement are in the same direction. So don't you see, at every point tension and displacement, the angle is 0, work is always positive, so the total work will obviously not be 0. Do you see that? The total work is not 0. So so it's for any fluid, Mohit Raj. For any fluid it is viscous. It's called viscosity. Okay. So EGL, you can put up a comment, bacha, I'll reply to that. Okay. So guys, what happens is, the total work is not 0. So do you see, is tension conservative or non-conservative? Come on, my warriors, let me know. Is tension conservative? Is conservative or non-conservative? Come on, my warriors, is tension conservative or non-conservative? Do you see that? Yep. Did you just see that? It's definitely non-conservative force. Yes, it's definitely non-conservative force because the total work done was not 0. As simple as that. Yeah. Great, clear, very good. So, going to the definition. So, force is said to be conservative if the work done by or against the force in moving the body depends only on the initial and final positions of the body and not the nature of the path. So, in fact, the total, I'll add to this statement, the total work in closed path is 0. Okay, this is very, very important. The total work in a closed path is 0 always. This statement says that, because the total work done in a closed path is 0, so when you come back to the same point, when you go around and come back to the same point, it also means one more thing. Just imagine, if I take some random point 1 and random point 2 over here, random point 1 and 2 over here, what it means, work done from 1 to 2, plus work done from 2 to 1 is 0. Everybody agrees? The total work done in a closed path is 0. 1 to 2 plus 2 to 1, whatever work is there, it is 0. Okay. Now shift this guy over there. So W12 will be negative W21, but remember, I can always write this negative sign from 2 to 1. Work done from 2 to 1, remember, work done from 2 to 1 is nothing but work done from 1 to 2. But there is a small catch, let me tell you. This W21 was from here via this path. Let me add it over here. This was this work. This was this work. This was the W21. So when I take it over here and W21, I take that minus, I absorb that minus sign inside. So I just replace those or interchange those subscripts. It becomes W12. What this means, you might be like, sir, W12 is W12. What nonsense? It's the same thing, right? No. This means when I go from 1 to 2 via this path, or whether I go from 1 to 2 via that path, it's the same thing, the same work will be done. That's what it is. EGL, because every time the force was opposite the displacement. Observe that carefully in that friction question. So W12 in red is this path, W21 is the black path. So if I absorb this minus sign, negative of W21 will be positive of W12, opposite directions. So what it means is, whether you go via this path or whether you go via that path, the total work remains the same. So it is independent of the path. It depends only on the initial and final position and not on the nature of the path. Whether you go like this or like this, the work done will be the same. Yes. Obviously, Mangalam, yes, it will be decent enough for CBSE, but for CBSE you need those special kind of questions. So for that you need to practice from back exercises and all of that. Examples: gravity, spring, electrostatic. All these are examples of conservative forces. Is everybody clear? Okay, so Saja, what's the confusion about? What's the confusion about? Okay, so okay, you want me to clear this again? So nothing but I'll tell you what, guys. See, if I go along a curved path like this and I divide the path into two parts like this, okay, two parts like this, imagine. Okay, so this is, I think you guys need some values, only then you understand. You guys don't understand variables because you have been brought up like that in school. School mein hamesha values. Sir, value do na, give me values. Why are you talking in terms of variables? Okay, so let's say from 1 to 2, from 1 to 2, you take, so W1, 2, you take 10 joules of work. Okay, now from 2 to 1, how much work will you take? From 2 to 1 via this path. Because the total work has to be 0, right? From 1 to 2, whatever work you do, 2 to 1, you have to do the exact amount of work because you are coming back to the same point for a conservative force. So you will take minus 10 joules of work. Now, if W21, from here to here, you are taking minus 10 joules of work. So from 1 to 2, in this black path, how much joules of work will you do? You will do plus 10 because I have flipped the sign, flipped these subscripts, I have interchanged them. 2, 1, I made it 1, 2. So it will become 10. So what it means is that if you go from 1 to 2 via that black path, you take 10 joules of work, and if you go via red path, also you take 10 joules of work. So don't you see, it's independent of the path. As simple as that. As simple as that. Yes. Why is it 0? Suchi Mama, it's 0 because it's a conservative force. So I have taken the example of a conservative force. Friction might be acting. Remember, work is work by that force. When you have a body, a lot of people have this misconception. There are multiple forces on the body. I am talking about one of the forces of all the other forces. By that force, it is 0. That force is conservative. Other forces might be non-conservative. As simple as that. Is that clear? Yes, got it. So multiple forces can act, but one of the forces might be conservative. Like when I'm walking, friction will act non-conservative, gravity will act conservative, normal will act non-conservative, air drag will act non-conservative. I might be holding a charge, conservative. So multiple forces will act. Each force might do, different work. Understand that because the directions are different. Yeah. I hope this is clear. Zayad, yes, your messages are visible. Non-conservative forces, like I just told you, in a closed path, those forces which not end up doing 0 work, they are non-conservative forces. And examples are tension, normal, friction, air drag. Yes, yes, correct. Hi Harshita. Now is it clear? Everybody? Jitesh, yes, bacha. Saja also clear. Suchi Mama also clear. Yes. Advanced session also. Yes, Ria. Now, the idea is, remember guys, remember in conservative forces, work done does not depend on the path, no matter how you go. But the moment you take non-conservative force, then it matters. You go from this point to this point, work will be different. You go from this point to this point, work will be different. Work 2 will not be equal to work 1. You go from like this to like this, work done will be completely different. All these paths will have different work because it makes sense, right? Imagine you push something like this, the friction will do some work. If you go via some other path, friction will do lot of work. If you go via some other path, then the friction will do some different work. Yeah, as simple as that. Okay, keep this in mind. Shall we do a question? Let's see whether you get it or not. This will be very interesting. Okay, so the closed line integral of force taken along a closed curve is given by integral f dot dl. Then if the force is f and it is conservative, then what is the value of this integral? Very interesting. Okay, think about it. think. As per the name, why is it conservative or not conservative? Rather, it is 0. Mohit Raj, why is your name Mohit? Why is it not something else? So you have to give some name, right? That's all. And by the way, Mohit Raj, you will see that in the next class that it has been given the name conservative because of some principle that it obeys. You will learn that in the next class when I talk about potential energy and all of that. Then you will understand. Yes. Okay, Remo. Remo, why don't you keep your name as Remo? It is so confusing. A, yep. So I'll tell you what this is. Cyclic. Okay, you might have not seen this symbol, but you should know this symbol from now on. Cyclic integral f dot dl. What is this dl? This is your displacement. Wait a minute, I know what is force into displacement. Force dot displacement is work. So it is actually integral of work. Integral of work, but this symbol which is there, this is called as cyclic integral. Cyclic integral means whatever term is there inside, you are starting from the same point and coming back to the same point. Initial and final both are same. So you start from here and go to some point, but that final point is the same. So basically the closed path work. What is the work done in that closed path? That will be zero. Reason, this force is given to be conservative. Yes, it's conservative. That's why it is zero. Everybody getting it? Now you got it? Excellent, Ikushi, Srimanti, very good, Kalyani, very good, Swarlina, very good, Ishpreet, Harita, Jitesh, crack with Gokulnath, Suchi Mama, very good, everyone, excellent. Great. So remember the symbol. This symbol is called as cyclic integral. That means you have come back to the same point, nothing else. Okay, let's get moving to the next question. A practice move along a curve of unknown shape. I'm guessing this was a particle. It is not practice. That's what I'm wondering. Why is it practice? So this is a particle. So a particle moves along a curve of unknown shape, but the magnitude of the force is constant and always acts along the tangent. My God, it's not talent, guys, it's tangent. Okay, really talented this is. Okay, so this is always acting along the tangent to the curve. Then the force must be conservative, may be conservative, must be non-conservative, may be non-conservative. Okay, chalo, let's see. Come on, my warriors. All right, come on. So somebody, I think Crack with Gokulnath has answered somebody's query, I guess. Sir, Roshni, both limits will be same in cyclic integral. You can think of it that way, Roshni. Yes. Hello, Adriti Niranjan, welcome aboard. Option A, option D, people are confused. So I'll tell you what you should do. My path could be, let's say, like this. This is my path. This is your path. A particle moves along an unknown shape, okay, and F is always constant. It could be a path. And this force is constant and always acts along the tangent, meaning the force is always like this. Tangent, 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 tangent. Don't you see, for this small displacement, this force and that displacement are basically parallel to each other everywhere. You move like this over here, you move like this, here you move like this, okay, you move like this, guys, this way. Displacement and force are always in the same direction, so they are parallel. That means the angle between them is zero. That means force dot ds will be what? It will be F ds cos 0. Think about it. Cos 0 is basically 1. So this is always a positive number. This is always a positive number. Every small displacement, you are doing positive work. So I apply some newtons for that 0.1 meter. I am doing positive work. Positive work, positive work, positive work, positive work, positive work, positive, positive, positive. So the sum of all the work, positive plus positive plus positive plus positive plus positive. If I come back, what will be the total answer? It will be a positive number, and it is definitely not 0. And if it is not 0, it must be non-conservative, which is option C. Is that now clear? Very good, Priyadarshini, Swarlina, excellent. Srimati, very good, Jai Star, Street Roshni, excellent, Zahir. Now I think you guys got it. It is not A. Yeah, it is not A. Yes. So you can think of it that every point it is doing positive work. Guys, remember the friction example? Friction example was exactly like this only. So when I talked about friction, see, the path was something like this, and at every point friction was opposite the displacement. Friction opposite the displacement. So every point the work was negative because it was anti-parallel. Cos 180 is cos 180 is minus 1. Every point it was negative work. So negative plus negative plus negative plus negative is going to give you a big negative number. So which is not 0. So that is why friction was a non-conservative force. Okay. So that's option C, guys. Let's move on to the next question coming up on your screen now. Beautiful question. Work from 1 to 2 is 30 joules. Sorry, 10 joules. Work from 3 to 1 is 30 joules as shown over here. Then from 1, okay, I think there is some printing mistake again, looks like. Okay, moving the particle from 1 to 2. Oh, no, it's fine. So 1, 2 represents, work done from moving from 1 to 2. W31 represents work done in moving the particle from 3 to 1 due to a conservative force. Very important. Then what is W32? What is the work done from 3 to 2? So 1 to 2 is known. 3 to 1 is known. What is the work done to move it from 3 to 2? Interesting question. Looks like Kalyani understood it now. Finally, Rajiv Pratap. So you need to give it some time. It always happens. Whenever you understand concept, if you give up very easily, then you will never understand it. But if you have some patience, for sure you'll understand it. It always takes some time. Physics is not easy. Okay, come on, my warriors. You are saying C. Some of you are saying C. Some of you are saying B as well. Okay. Some of you are also saying A. Interestingo. Okay, Jayastar. Well. Come on, my warriors. Okay, let's do this. W12 is 10. W31 is 30. Acha. So W31 plus W12 plus 31, 12, 23. This is a closed path. Think about it. This is a closed path. You can see why it is a closed path. This was my initial position. This was my final position. And initial and final alphabets both or subscripts are the same. So this answer must be 0. Reason, it is a conservative force. As simple as that. What is this? Well, 31, that's 30. What is this? Well, that's 10. So that will be W23. Yep, this is equal to 0. Now take this on the other side. So W23 will be minus 40 joules. But be careful, you have been asked W32. So W32, opposite of that. So plus 40 joules, which means option B is correct. Option B is correct. Correcto. A lot of you got it wrong. Yeah, read the subscript. 3-2 has been asked, not 2-3. Yep. Thank you. Glad to know that, Adhriti Niranjan. I hope you stay with us, stay with me till the end. Trust me, I'll make sure that your syllabus is completed not just properly, but also you understand, enjoy, and you score really well. You will crack JEE. Don't worry, bacha. Okay? So stay with us. Alright. Now let's talk about kinetic energy. Very good, very good. Is circular motion always conservative? No, Harita. In circular motion, the forces acting may be conservative or non-conservative. It depends on the force. Let's say the particle which is moving in circular motion, the force acting on it is gravity. That gravitational force is always conservative. Friction, non-conservative. Spring, conservative. Okay, so it depends on the forces. Okay, chalo. Join in Gauri Shankar little bit late. Zayed, yes, bacha. Oh my god, 2024 student. I know you are very young, and it's really nice to see young students like Zayed and Gokulnath out here who are really challenging the 11th standard students. Congratulations, guys. Alright, now kinetic energy is the energy because of motion. Yep, energy because of motion. Anything which is moving, it has kinetic energy, and you know that. Imagine some guy who is very tall and fat in your class. Yeah, imagine a guy. He starts running towards you. Won't you get scared? Just imagine a tall a very huge guy, bulky guy in your class. You might have seen your friends maybe 1 or 2 years back. Remember those golden days when you used to go back to school and eat out freely in restaurants, and you don't have to wear those masks out there, and open. So yeah, there would be a tremendous amount of kinetic energy. The mass is more, the velocity is more, and let's say that fat guy, I don't know, I'm just going to call him Pandu, okay? Let's say we just call him Pandu, and this Pandu, and he is running like crazy, okay? Like, I don't know, 20 kilometers per hour. That is still huge, guys, for a human being. He has some kinetic energy, and you are not going to ask him, is your kinetic energy in the north direction or in the south direction? Because it's a scalar quantity. It doesn't matter which direction it is, he has that kinetic energy. End of story. Okay? Velocity is a vector, speed is a scalar. When I square velocity, the directional information vanishes. V square. So even if there is a negative sign, it vanishes. So it really doesn't matter what's the direction. So it's a scalar quantity. Unit is in joules. Energy is always expressed in joules. Work is also in joules. So it is in joules. You can also write it as momentum square by 2m. As simple as that. When do we conserve energy? Shreya, the inquisitive mind. Looks like you're really inquisitive, Shreya. We are going to talk about energy conservation in my next class next week. So hold on for that. For this, the entire setup needs to be built. So mahol banana padega. So just hold on. Next week, I'm going to talk about energy conservation. All right. So P is momentum. Okay. I hope you get this. This is P square by 2m. You can easily get that because you can always write half mv square as half m square v square by m. Mm gets cancelled. Okay. So P square is m square v square. You can see that it's the same thing, nothing else. All right. Let's solve some questions on your screen. Here it is. And we have a truck, a car, and both of them are moving on a smooth leveled road such that the kinetic energy associated with them is the same. When you apply brakes on both of them simultaneously, which one will cover greater distance before it stops? Okay. Oh, why it is half mv square? Well, there is a derivation for that, Suchi Mama. I have derived that in my derivation course of 11th standard. You can check it out. It's all there in the pro subscription. Alright, so I have derived why kinetic energy is half mv square. Why not m square v? Why not that? So it comes via derivations. It's there in the derivation course. Alright, so a truck and a car are moving on the same, on a smooth level road such that the kinetic energy is same. Brakes are applied to both of them simultaneously. Okay, guys, there is a mistake over here. This should be rough. My bad. It can never stop on a smooth surface. It can never stop. Okay, so that's the catch. I mean, like, that should have been rough. My bad. All right. So many of you are saying B. Many of you are saying the truck. Okay. Well, I'll tell you what. See, their kinetic energies are same. Okay. So kinetic energy is half m v square. For them to stop, if it has some velocity, it stops. Okay. There must be some retardation. And that retardation will be the retarding force divided by mass. This is using Newton's law. Okay, Newton's law. Acceleration is force by mass because F is ma. What is that force? That force is friction. And that friction will be mu mg divided by m. Mu is coefficient. Goes. So acceleration is just mu g. I thought everybody has understood this. Acceleration is just mu g. Now, if you use kinematic equations, you will see v square is u square plus 2s. So final velocity is 0. Initial velocity is v minus, because it is retarding, 2a into s. So 2as is equal to v square. So 2a, a is nothing but mu g into s is equal to v square. So s, mu is same, g is same, 2 is same, is directly related to velocity square. If displacement depends on v square and v square is, oh, there is a problem over here. Look at that. Both of them, it's clearly mentioned, the kinetic energy of both of them is same. It's the same. It's clearly mentioned. The kinetic energy is same. So the one which has more mass will have less v square. The one which has less v square, because the product has to be same, the one which has less v square will have more displacement. Oh, sorry, my bad. What did I do? So S square, so it will have less displacement. Yeah, so the one which has less V square will also have less displacement. So who has more mass? Truck. So truck has more mass, so truck will have less displacement, so car will have more displacement before it stops. So hence the answer is car. Yep, as simple as that. So guys, yes Jitesh, lot of you would have thought, sir, truck is very heavy, so it will stop later on. No, in fact the question said the kinetic energy was same, velocity was not same. So be careful about it. So things are different. So read the question, what is same, what is not same. Based on that, you should answer. I know many students would have answered truck will stop later on, but this question when it comes in JEE, many of them are going to lose marks, and those of you who are going to think logically, stepwise, pure mathematics, apply the laws of physics, only then you'll get the correct answer. Don't go by gut feeling. So the answer is A. You can see that. Yes. Very good. Yep. I hope this is clear. Kinetic energy is same. If kinetic energy is same, masses are different, so speeds will be different. So speeds are different, obviously things will change. Okay. Next question coming up on your screen, ratio question. Okay. Priyadarshini, I am conducting problem solving sessions for 11th standard in the pro subscription. There is a micro course which is running. You can check it out. I have solved different good level problems right from vectors till the last chapter, and beautiful. These are my problems. You are not going to find this anywhere on the internet. You can check it out in the part of pro subscription. It's all there. Okay, so that way you will learn how to solve problems when you see me solve problems. Plus HC Verma course is there, derivation course, all these courses are there in the pro subscription. Okay, so these two bodies have some masses. What's the ratio of the momentum? Acha, kinetic energy is momentum square by 2m. So therefore P square is 2mk. Therefore P is root of 2mk. Therefore P1 by P2. If I take ratio, 2 will get cancelled and I will be left with m1 by m2 into k1 by k2. So what is m1 by m2? Masses in the ratio of 5:1. Kinetic energy in the ratio of 125:9. So 5 into 125, that's 625 divided by 9. 625 is root 25, 9 is root 3. So 25 by 3. Oh, not 5 by 3, Saja, it's 25 by 3, bacha, be careful. Yes, that's it. Yep. Okay. All right. So, Shreya, I feel you should start with HCV, bacha. I'll tell you honestly feedback. Don't start with Pradeep, because HCV is meant for Indian crowd. Plus, it has accurate theory, apt theory with good problems, very simple to medium to then hard problems. Number 2, HCV solutions are available in Vedantu for exercises, plus the discussion questions whose answers are not there on the net accurately anywhere. I have conducted a Vedantu Pro subscription course, micro course, so you can check out that short answer course of mine for HC Verma. I have discussed all the chapters solutions. Okay, chalo. Can you use HCV for can you use HCV for NEET as well? Yes, Shalini. In fact, you should, because if you see the NEET paper, it has good number of concepts, and HCV has those concepts which are apt. A lot of people recommend out there different books, but I find that people who study from HC Verma are those people who get above 160, 170 marks in NEET out of 180. So guys, please start using HC Verma for NEET. Okay, don't think it is only a JEE book. So 25:3. Let's move on to the next one. But before that, if you have any doubt, use our Vedantu app, and you can take a screenshot and share the picture of your doubt and chat with our doubt experts real time from morning till night. There is no cap or limitation on the number of doubts you can ask, and you will get all your doubts cleared within our doubt app. It's all for free. Yes, as many number of questions you want to ask, it's all for free once you're in the Vedantu Pro subscription. Let's move on to the next part, which is work kinetic energy theorem. Okay. Now, here is what we should do. Well, Ankit, yes, you should start solving PYQ also, bacha. It's very important, from Arihant or from Tattva module. What is this work kinetic energy theorem? I'll give you some examples. Okay, simple. Let's say I drop a ball. You drop a ball. What happens? Gravity will act. After some time, this ball gets some velocity. Where did it get this velocity from? Well, gravity. If gravity was not there, it would not have got. So, is gravity doing some work? Yes, it is doing some work. Displacement was downwards. So, remember last lecture I had told you about how work is a process of transfer of energy. Remember I had drawn two Pandus and they were exchanging money. So, the process of transferring energy. So, one guy's energy decreases, other guy's energy increases. That is nothing but called as work. Same thing over here. What has happened is that gravity has transferred its energy to the ball in the form of kinetic energy. So what has happened? Gravity has done work and given, that's the process. So the work by gravity has gone into increasing or providing the kinetic energy to the ball. As simple as that. And see this beautiful. Yes, it's a process of transferring work. I can give you even more examples. Say for example, this one. Imagine you have a ball here, okay, and let's say it is rolling like this, and let's say there is a spring. Okay, there is a spring over here. Okay, this ball comes and it compresses the spring. The spring gets compressed like this. Okay, now when this ball comes and it goes like this, there are multiple forces acting on it. One is normal force, other is weight, and when it hits it, there is also the spring force. Spring force is also there. I will call it as Fs, apart from normal and weight. Now, as it moves, as it displaces over here, if I ask you, what is the work done by normal force? What will your answer be? Answer will be 0 because normal is perpendicular to the displacement. So work done by normal is 0. Okay, done. What is the work done by weight? Weight is down, displacement is here. So that is also 0. Friction, let's ignore for some time. Okay, Shalin, let's just ignore because I just want to explain you some concept, okay? So work done by a weight is also 0 because it is perpendicular. This is also perpendicular. If I ask you, what is the work done by the spring? Look at it. Spring and displacement, opposite direction. Opposite means negative. So work done by the spring force, isn't it a negative? Because they are opposite in directions. So if it is negative, what has happened? There was some kinetic energy. Now the kinetic energy went away because it stopped. The spring absorbed it. Negative work. Negative means absorb. You take it away. You are doing pop. You are sucking away that energy. That's what the spring has done. So it's done negative work. So that has changed the kinetic energy. The change in the kinetic energy is also negative because the final is 0 and initial is positive. So final minus initial. Final is 0, initial is positive. 0 minus a positive number is a negative number. So work is change in the kinetic energy. Do you see that? Yes, do you see that? So whatever work the spring has done, normal and gravity did not do work. So the total work done has gone in changing the kinetic energy. As simple as that. Dayani, please start from beginning, bacha. You can roll over, you can take the slider to the beginning and you can watch it at 2x speed also if you want to. Okay, so that's the whole idea about work kinetic energy theorem. What is work? Transfer of kinetic energy. So that's the process. So work, according to this principle, work done by all the forces, internal, external, everything will, when a body is moving, not moving, doesn't matter, when displacing the body, it goes in changing the kinetic energy of the system. That's it. As simple as that. The total work done, all forces, internal, external, blah, 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 conservative, non-conservative, doesn't matter. will go in changing the kinetic energy. So basically this is work done by force 1 plus work done by force 2 plus work done by all the forces will be final minus initial kinetic energy. That's what this statement is. Whatever work you do goes in changing the kinetic energy. As simple as that. All right, very good. So if you want the derivation, I have put it over here. Okay, you can check it out later on, but let's start applying this principle in problems. It will be there in the PDF, by the way. A car of certain mass is moving with certain speed on an expressway, and if you change the speed to 90, how much work will be required to do so? So for getting 100 percentile deleted, you need to solve from HC Verma, you need to solve from previous year questions, and you need to solve Tattva module, and then you need to solve Erodiv. So these are the 4 books I recommend for getting 100 percentile. These are my recommendations. Okay, cool. Very good, Swarlina, it's clear. So now you might be like, sir, what's so special about this question? I'll tell you what is so special about this question. You see, 54 kilometers per hour multiplied by 5 by 18, and you're going to see this is nothing but 15 meters per second. This was initial speed. Okay, this was initial speed, and this one over here, well, multiplied by 5 by 18, that's 25 meters per second. That's the final velocity. The question is, what is the work done? Don't you see the car is actually accelerating? So what you could have done, you can find this acceleration using V is initial velocity plus acceleration into time. Velocity, initial velocity, oh, time is not known. Achha, so what do I do to find out acceleration? I can use third kinematic equation. V square is U square plus 2AS. V is known, U is known, S I don't know again. Achha, that's also a problem. So, I don't know the acceleration. You'll be like, sir, why do you want the acceleration? Because to calculate the work, it is force into displacement. Achha, and force is nothing but mass into acceleration, and for that I would need it. But then you'll be like, sir, force is mass into acceleration. Acceleration into displacement is something which you can find from here. So if you can find it from here, then you can put it here and then solve the problem, and then you'll get work. Don't you see it's a lengthy process? Don't you see it is a lengthy process? We can avoid all this, okay? We can avoid all of this. How do you avoid all of this? Very simple. Use work kinetic energy theorem. Work is final minus initial kinetic energy. So half m, what is m? I don't know, but let's just put it as m. V final square minus V initial square. So let's just put it. Mass is 800. Final velocity, well, that's 25 square minus 15 square. That's going to be 400 into 25 square, that's 625. And you have 15 square, which is 225. So that's going to be 400 again. And 4 fours are 16, 2 zeros. So this is 160, I guess. Yes, 160. 3 zeros over here will become kilojoule. That's the answer. Isn't this easier than this? Isn't this easier? Okay. So Shreya, how about this? Leave a comment after the video and I'll definitely reply to your query. Okay? Just do that after the session ends. You can leave the comments. So now you understand the importance of work kinetic energy theorem. It has avoided Newton's laws and kinematic equations. So 2 concepts were there. This was, there were 2 concepts here. I just have to use work kinetic energy. Let's move on to the next question coming up on your screen. Yes. So Vikram, I know it is a Laddu question, but this was to make you understand the importance of work kinetic energy theorem. Moving on to the next one, the velocity of a body is given by this. Find the work done. Oh, interesting. Velocity is a function of time. Guys, whenever velocity is a function of time, you need to find out displacement, because remember, work was integral f dx. Now, how do you find out force? Force is mass into acceleration. Achha, I don't know acceleration. You'll be like, sir, acceleration I know, sir, dv by dt, sir. Okay, fine, we'll get dv by dt, but this is dx. You cannot integrate a time function with a dx. Whatever you get, dv by dt, okay, dv by dt might come out to be 3 into 3, which is 9. 9t square minus 0. You cannot integrate this with dx. Then you need to do some transformation. Zaid is saying s is ut plus half a t square. No, you cannot use it. Acceleration is not constant, bacha. Kinematic equations are only valid when uniform acceleration is there. This is a non-uniform acceleration. Time is changing. Velocity will change rapidly. Acceleration is not uniform. You can see that it's definitely not constant. So to avoid all this nonsense, look at this. What I'll do. Work is final minus initial. Work kinetic energy theorem. Half m. 3 seconds, right? So velocity at 3 seconds minus velocity at 0 seconds. Half, what is the mass? 2 kg. Okay. Velocity at 3 seconds. Put the value of time as 3. So it will become 3 into 3 cube minus 1. Okay. Whole square. Okay. This is multiplied by minus. Put the value of time as 0. So it will be 0 minus 1 whole square. Whole square. I hope this is fine. Now what will this become? This will become 1. And what is this, guys? Check this out. What is this? This will be nothing but 3 cube is 27. 27 into 3, that's 81. 81 minus 1, that's 80. So this will be nothing but 80 square. Correct? And on the other side, what do you have? You have minus 1 square, which is basically 1 itself. 6, 4, 0, 0, minus 1. So what is the final answer? It is 6399 joules. That is the answer. You can just get it. Everybody got it? It is minus 1 square. Be careful, Gauri Shankar. Minus 1 square is 1. Be careful. Gauri Shankar, you made a mistake. Minus 1 square is 1. Be careful. So it is minus 1 only. Okay, understood? Yep, very good. So it is not 6.3 kilojoules. If you want to write it, it will be 6.399 kilojoules. 6.399 kilojoules, which is approximately 6.4 kilojoules. Approximately. Be careful. Yep. Everybody got it? So approximately, this is an approximate answer. Exact answer will be 6.399. Let's move on to the next question. Can you also do it by differentiation? Yes, you can do it, but it will be lengthy. That's the whole point of teaching you work kinetic energy theorem, because you can avoid derivatives in many cases. That's the whole idea. Okay, chalo. Let's get moving to the next question coming up on your screen. Now, this mass collides with the spring. It has some momentum. After the collision, the block stops after compressing the spring by how much distance? Yes, compresses it by L. Interesting. Yep. Okay, happens sometimes. Crack with Gokul. Alright, so some of you are saying option C. Let's do this question. Where is the pen? Yep. So once this spring gets completely compressed, this block is over here. It has stopped. The final velocity is 0. Initial velocity is this way. Okay, and we know that the displacement has happened like this with a length of L. The spring force would have been acting this way, Kx. What is this Kx? This is the spring force. Now, apart from the spring force, there are one more forces, which is normal, and there is also mg force or weight force. According to work kinetic energy theorem, work done by normal plus work done by mg plus work done by spring, all these forces together will be final minus initial kinetic energy. What is the work done by normal force? Well, the displacement is here. Normal is like that, perpendicular. So the moment it is perpendicular, gone, 0. Okay, so that's what it is. Work done by gravity, gravity is down, displacement is there. It's again perpendicular, gone, 0. Spring, now that's the problem. Lot of people are going to say, sir, force into displacement, Kx into L. Wrong. Kx is a variable force. This is variable force. The moment you have variable force, what do you guys do? integration, guys. Integration. Is that clear? Yes. You're going to do integration. Yes, variable force. So you're going to write integral kx, force into displacement, but with a minus sign. Why minus sign? Because force and displacement are opposite in direction. So work done will be negative. From 0 to L. I hope this is clear. Force dot displacement. That's the work done by the spring. Final energy, that's 0. Initial kinetic energy is p square by 2m. Why am I writing it like this? Because they have asked what is the momentum of the block. What's the momentum of the block? Okay. And in fact, they have asked what is the maximum momentum. Is equal to p square. L. L is nothing but your displacement. And force is this way. Force is opposite to the displacement. So that's why negative sign. I hope that makes sense. Okay. Shreya, last lecture I have talked about integration of a variable force. So probably you should check the previous class. This is because work done by variable force is integral f dx from initial position to final position. That's it. Initial was 0, final is L. So that's it. Force was kx. So that's what I have done. That's it. Let's solve one more question, guys. Yep. Yeah. And why that negative sign? The negative sign was because the displacement was here, force was opposite. So whenever force and displacement are opposite, the work done will be negative. So that's why it is negative. All right. Let's get moving to the next one. Okay. Let's see whether it is correct. Yep, it is correct. Option C. Moving on to the next question. Ankit, join my Erodo solving course, bacha. But before that, I'll tell you, before solving Erodo, it's not a good time to solve Erodo right now unless you are topping and acing in all the mock tests. You should solve Erodo after you are very thorough with the complete syllabus, very thorough. Like you are very confident. That's when you should pick up Erodo. Before that, don't pick up Erodo. That will be a big mistake. Okay. Now let's start solving this question. The speed of the bob of mass m from the pendulum of length L when it reaches the bottommost point and initially the string makes some angle theta with the vertical. Okay, beautiful question. Let's see how to do this. So the bob comes like this. This is the path taken by it. It comes like that and it has some velocity. Let's say I call it v and it is released from rest over here. Fair enough. Now the question is, what's this speed? Guys, can I use kinematic equations for this? Can you use kinematic equations somehow and say, yeah, this is displacement, okay, and this is the acceleration, and therefore velocity is dependent on this acceleration, this is a displacement? No, I cannot use it. Very good. Why I cannot use it? Yes, the reason why I cannot use it is because acceleration is not going to be constant, number one. Number two, this is circular motion. This is like crazy. Acceleration won't be constant. It won't accelerate the same way. It will not be constant. So you cannot use kinematics. So you should think, okay, maybe it's got to do with energy and work and all of that. So let's think about the forces acting on it. And the forces acting on it, if you see at any given instant of time, okay, there is one force which is tension and the other force which is gravity. Okay, now I think I got some idea. Final velocity I want to find, initial velocity is 0. Now you should probably be getting that idea. Work done by tension plus work done by mg will be final kinetic energy minus initial kinetic energy. Now comes the biggest question in your life. What is the work done by tension in this entire path? Let's see who can answer this in maybe 10 seconds. Quickly, how do you calculate the work done by tension in this curved path? What is the answer? Come on, my warriors. Think about it. Yes, the direction will keep changing, Shalini. Very good. Good thinking. Tension will keep changing the direction, but mg will always act downwards. Come on, think. Excellent. You have answered it, and the answer is 0. The reason why it is 0 is because every time it moves, where is that path? The displacement. This is how the displacement is, and that is perpendicular to the tension. Remember, this is always perpendicular, no matter where it is. Even here, it was perpendicular. So shouldn't this part be 0? So I don't even have to worry about tension. Get rid of it. Excellent. Now, like, sir, mg is like this. Path is curved, sir. Displacement is changing the angle, sir. How do you find the work when displacement itself is changing angle? I need to use integration, and some books will also use integration. But the problem is, or rather the benefit of mg being the conservative force is that I can choose my own convenient path. I can choose my own convenient path. No, it is Saja, this is Lallu mains question. This is one of the easiest question. If this question comes now, you ask any 12th standard student, he will dance on 1 feet and he'll be like, oh my god, such an easy question, I have to do it, I will get +4 marks. This is like damn easy, easiest question ever you can think of. You are finding it difficult because you are seeing it for the first time, so don't get scared, bacha, you will understand it. Learn with me. Acha. Now think about it, isn't gravity a conservative force? So work done by gravity is independent of path. Okay, let me just put it over here. Let me just put it over here. This is conservative force. And whenever you have a conservative force, the work is independent. It's independent of the path as long as the initial and the final positions are the same. So how about choosing a convenient path? And my convenient path is this and this. You'll be like, sir, what the hell? Why would you do that? Hold on, I'll tell you why I did it. Observe. Tell me one thing. If I replace the blue path with the green path, the total work won't change, right? It will remain the same. Think from here to here, gravity is acting like this. Isn't it perpendicular? So shouldn't this mg do 0 work from here to here? Shouldn't it do 0 work from here to here? Everybody getting it? Everybody clear? Yep. No Lakshmi Narayan, it is not 2L. Hold on. Yes, Bhargava will be completing all the topics, obviously. That's the best part. Now, here, this displacement I can easily calculate. How? Think. This is L. This is theta. So, this is in this triangle L cos theta. But this whole thing is L. This whole thing is L. So, this much, just this much, okay, just this much. How much will it be? L minus L cos theta, which is L into 1 minus cos theta. Why did I find this out? Because in this region, mg is like a constant force. Force and displacement are in the same direction, so I can easily simplify the problem. So that curved path ka work has now been simplified into this work plus this work. Out of that, this work is already 0, so only this work has to be calculated. Isn't it simple? Did you guys understand why we chose this path? So I have chosen a convenient path. So that's the advantage of conservative forces. That's why I taught you conservative forces and gave you that property at the start of the class. So you can use it while using work kinetic energy theorem. Now let's use it. So work done by mg. How much will it be? mg into displacement, L into 1 minus cos theta. Final energy half mv square. Initial energy 0. m goes. So gl 1 minus cos theta is equal to v square by 2. 2 goes there. So v square will be 2gl 1 minus cos theta. Therefore v will be root of 2gl 1 minus cos theta. That's it. Done, done, done. What a brilliant question. Very good, very good. You guys understood it. Excellent. So a lot of people skip this question and not many people discuss this question in this detail because many people don't know, acha, tension was doing work or not doing work. They don't realize that even if tension was there, it was not doing work, so don't have to worry. Gravity, well, it was doing work in a curved path, but I can replace it with a convenient path. This part didn't do work, this part did work. This was L, this is L cos theta, this is L minus L cos theta. Put everything, you get the answer, done, done, done. This is formula, sir? No, Shalini, this is not formula. This is application of kinetic energy theorem, work kinetic energy theorem. That's the title of today's class. Learn how to solve. What have you learned in today's class? How to solve and approach problems. Why did you learn work kinetic energy theorem? When you are able to see a problem, are you able to identify, oh, is this a work kinetic energy theorem, and how to use it? That's what I want you to learn, bachalo, in today's class. That's all. Okay, so that's the answer. Now I have kept 2 questions for you guys for homework. Try to solve this at home. A particle is projected at this angle. So projectile combined with kinetic energy and a variable force and work kinetic energy based question. Let's see if we can solve it. And guys, if you want to take up my courses, please take it up, because I have this micro courses for you guys. One is the numerical problem solving, and then you also have my HC Verma course, you have my derivation course for 11th standard, all of this, and this is also there. Erudov course is also there. All of this for 11th standard student. Remember, the batches are starting on Monday, and you have the option for choosing English or Hindi, but by default you will be put in English batch. So this is the default batch you are being put, but if you want to shift to Hindi, you are free to do that. You have a choice of teachers, lot of teachers like me, all are from IITs or NITs or top-notch colleges only. Okay, so they are all from top research institutes, and you will have lots of parent-teacher meetings and guidance sessions. Okay, guidance sessions and all of that for all the batches that you are going to be enrolled into. Apart from the tests and assignments you will get with lots of questions, there will be also Tattva module. This is the hard copy which will be provided to you. So hard copy of the Tattva module will be provided to you, and apart from these classes you will also get your KVPY classes and all other things like example like CBSE. If you want to prepare for CBSE also, there are classes for that as well. So all of this is under one roof. Okay, all of this is under one roof. You don't have to go anywhere after joining Vedantu, and there are 3 packages. The light version will have all the things what I told you, but if you want the doubt solving on the mobile app, then you need to go for the classic version. And if you want the personal mentor, then you go for the plus version. The batches are starting this Monday in September, and the prices are hardly 3,500, 600 per month, and you can get this discount using my coupon code SHHPRO. The link is there in the description box below. All right, so thank you guys. And long term, yes, Chinmay, there is a long term batch as well. Like I said, the batches for long term is starting. All right, September, Monday. What will mentor do, Chinmay? Mentor will help you arrange timetables, or let's say you are facing some personal issues. A lot of students have some personal issues. They will counsel. They are basically trained to understand the child's psychology and counsel them. Also, sometimes students are not able to find time. They will help them manage that time, or give them strategies for how to make those timetables. And regularly they will ask the students, how many questions have you solved, bacha, or all those things. So that's what personal mentorship is all about. Okay, so mains 2022 Jadoo Beats, I have conducted a class for mains 2022. Just search Shreyas Sir strategy 2022 mains, you'll get it. I have listed down all the topics, just check it out. Okay, I think you can do that. Yes, Ankit, I'll do that. All right, Priyadarshini, bye bye, take care. Next session will be on potential energy and mechanical energy conservation next week. Okay, Zayed, bye Saja, bye Suchi, bye everyone, bye bye Ishpreet, take care bacha log. And this was Shreyas here, and I was going live from Bangalore, and hasta la vista.